Hello everyone, myself Dr. Seema from Alobasics. Today we'll discuss about AC circuits, which is 13th chapter from the 12th physics of Maharashtra State Board. Let's study next article from AC circuits, that is average and RMS values.
Now, before going to this average value and RMS value, we must know instantaneous value. What is instantaneous value? Once we know, then we proceed further. So, whenever we talk about alternating current or alternating EMF, we must know about instantaneous value, average value, and RMS value. So, let us start with that. And first, instantaneous value. I consider again a wave. From our last time's knowledge, we know that as wave is starting at 0, we say that this wave is sine wave. It may be representing EMF or voltage, but since here I have written 10 volt, 5 volt, so I say that it is an alternating EMF, or this wave is representing alternating EMF. Now here we can see that at different point, different values are given. If I consider this point, at this certain point I say that how much is the value of EMF? That is 5 volt. Here it is 10 volt, again 5 volt, but at this point it is minus 10 volt. Now I can see here the peak value for this. On the positive side plus 10 volt, on negative side it is minus 10 volt. So peak value on either side is always same. Now on positive side 10 volt and negative side also 10 volt. So here instantaneous value, when we want to talk, I say that here voltage is 10, here there is 5, here there is 5. In between these two, it might be ranging from 5 to 10, or here it is ranging from 5 to 0, 0 to minus 5. So, all these values which are represented at particular point, at particular time, because this is nothing but the time axis, here it is shown, and so at this time value is 5 volt. At this particular time, value is 10 volt. At this particular time, value is again 5 volt. Here it is minus 5. Here it is 10, minus 10, so on. And due to that, here I say that at different point, value of EMF is different. It is not constant. It is varying from positive to negative, and due to that, we say that instantaneous value is value of alternating EMF or alternating current at a particular instant, or I say that position, because this is one position, this is another position, like that. I can say that at different time or at particular time, at that particular instant, whatever is the value of that EMF, that or current, that is known as instantaneous value. Now as I am having this instantaneous value and it is continuously changing, so if I want to measure this alternating EMF or such type of alternating current, can I use ammeter and voltmeter? Can that ammeter and voltmeter will measure this? What is the answer? Definitely answer is no, because as it is varying, it is not able to measure the value. So what to do? Let us try for average value, because always ammeter and voltmeter measure average value, and as it measure average value or as it measure mean value, we have to find out its average or mean value. Now what is average or mean? For that again we'll consider this sine wave. In this sine wave, if I want to find out average, what is procedure for finding average? What we do for finding average? क्या करते हैं हम लोग जो भी रीडिंग है वो सब रीडिंग्स ऐड करते हैं और उनको नंबर ऑफ रीडिंग्स से डिवाइड करते हैं. अब यहाँ मेरे पास 9 रीडिंग्स है, मैं इन सबको ऐड करते जाऊंगी. When I add this, I know that out of that 3 readings are 0. Then on this side, I have plus 5, plus 5, plus 10, that is 20. Similarly, on the other side, on the negative side, minus 5, minus 10, 15, minus 5, 20. So this 20 plus 20 minus 20 plus 0 plus 0 plus 0, total will be 0 and my average value will be 0 by 9. Now I'm taking here only few values. I'm not taking all values. Average over one complete cycle in given wave is always 0. As that average is 0, can I measure it? Again, it is difficult to measure. Doing that part, or I'm finding out average of a sine wave just by adding few number of readings. सही है, क्योंकि मैंने क्या किया है, सिर्फ 9 रीडिंग्स लिए, बट इसके बीच में काफी सारे रीडिंग्स है, काफी सारे वैल्यूज मुझे आने हैं. तो क्या ये सही है? ये तरीका सही है? नहीं. अगर मैथ्स के बारे में सोचा जाए तो ये तरीका सही नहीं है. हम एवरेज कैसे निकालते हैं? दिस इज अ साइन फंक्शन. If I talk about EMF, I know that alternating EMF is either given by E is equal to sin omega t or E is equal to E0 cos omega t. ये हमने लास्ट टाइम देखा है कैसे रिप्रेजेंट करते हैं. दोनों वे में हम रिप्रेजेंट कर सकते हैं. Now if I say that it is E is equal to E0 sin omega t और E is equal to E0 cos omega t, मुझे एक बात यहाँ दिखाई देती है कि E किस पे डिपेंड करता है? टी पे डिपेंड करता है. ई कैसे चेंज होता है? जैसे जैसे टी चेंज होता जाएगा, ई चेंज होता जाएगा. व्हाट इज E0? E0 is the maximum value. Here I say that E0 is 10. And as E0 is 10, is it changing with time? No, it is constant. So E0 is constant. So what is changing? As t is changing, sin omega t is changing, because omega also for this particular alternating signal, omega is constant. We know that its value is given by omega is equal to 2 pi by t. What is capital T? Capital T is the time required for one complete cycle. So from this position to this position, whatever is the time duration between these two, that is nothing but time period, capital T, and omega is given by 2 pi by t. Now here I can see that E is a continuous function of t. Similarly, I know that alternating current I is also represented as I is equal to I0 sin omega t or I is equal to I0 cos omega t. So that is also a continuous function of t. And when we are having a continuous function of any variable, because t is here variable, so a continuous function of any variable, then there is a procedure to find out its average value. And for that, now I consider a function. Suppose this is a graph of a function f of x, or I say that function is y is equal to f of x. That y is varying in this way as y is equal to f of x. Now I want to find out its average for this shaded region. Within this region, how much is the average of this particular function that I want to find out. Then how to find out that? For that, average of the continuous function is given by average of f of x is equal to, this is the symbol for average, is equal to integration of f of x dx from the lower limit a to upper limit b divided by b minus a, that is upper limit minus lower limit. More specifically, I say that this is given by integration of f of x dx from a to b, same divided by this b by a. Now I write as integration of dx from a to b. So lower limit is a and upper limit is b. Or in other way, I say that in this case, this is the numerator is representing addition of all the values and denominator is representing the total number of readings. And with the help of this, we can find out average for any continuous function. Now the same thing I want to apply for alternating EMF or alternating current. Now I'll apply it for alternating current. I say that this is a alternating current. We know that it is I is equal to I0 sin omega t or I0 cos omega. I is a continuous function of t, and as it is continuous function of t, when we have to find out its average over a complete cycle, we'll use its average as average of I is equal to integration from 0 to t I dt divided by integration from 0 to t dt. Now from where this equation has come? This equation has come from our earlier equation which we have studied, that average of f of x is equal to integration from a to b f of x dx divided by integration from a to b dx. What is a and b? A and b are limits of integration, that is lower limit and upper limit. Now same this technique we are using for finding average of current, as this is average of f of x, where f of x is a continuous function of x, and here we are having I as a continuous function of t, so we are taking integration over dt. Now why I am taking limits of integration here from 0 to t? Because we know that when we talk about complete cycle, for that complete cycle, time duration is time period, and due to that we are taking it as from 0 to t. How we are taken for complete cycle, how time duration is capital T, that we have studied earlier, so we are familiar with that. And now as I'm substituting here limits of integration from 0 to t, numerator is giving me the total amount of current over a complete cycle, and denominator is giving me the total number of readings or total number of values. Number of values I'm talking, its addition is given by denominator. So here now, as we know that I is given by I0 sin omega t, I'll substitute value of I as I0 sin omega t. And when we are substituting this, we know that I0 is independent of t. I0 t पे depend नहीं करता है. I0 is constant as per the time is concerned. And due to that, we'll take I0 outside the integration sign. And when we are taking I0 outside the integration sign, we can write it as I0 integration from 0 to t sin omega t dt divided by t minus 0. अब ये t minus 0 कहाँ से आया? t minus 0 हमें ये इंटीग्रेशन सॉल्व करके मिलेगा. What is integration of dt? Integration of dt is t. So for that t, I have to substitute upper limit first, minus lower limit as per integration. All of you have studied this integration part in your maths, so you might be familiar with that. And when I'm substituting these limits of integration, I'll get here t minus 0. Now, I want to do integration of sine omega t. And what is integration of sine omega t? Integration of sine omega t, we are taking over dt, but here I am having omega t. So omega is again here constant regarding the t term, but here I cannot take this omega outside because it is enclosed in sine value. And due to that, while we are taking its integration, we have to take care of that. So integration of sine theta is minus cos theta. As integration of sine theta is minus cos theta, here we write that sine omega t, integration of sine omega t is minus cos omega t. And as I told you, omega is constant, that omega will come in denominator. Or integration of sine omega t is minus cos omega t divided by omega. So this entire term we can write as I0 n bracket minus cos of omega t with limits of integration from 0 to t divided by omega t. T is from here we are taking t, and as I told, omega from the integration process we came across omega. Now again, if we simplify it further, we get here this minus sign I'm taking outside. As I'm taking minus sign outside, I'll get minus I0 divided by omega t, and here we are substituting limits of integration. So cos of omega capital T minus cos of 0 upper limit and lower limit, and here now we substitute value of omega t. We know that omega t is equal to 2 pi. So if I substitute that, here I'll get this minus I0 upon omega t cos of 2 pi minus cos 0. What is value of cos 2 pi? Cos 2 pi is 1. Cos 0 is also 1. So here we'll get minus I0 upon omega t, 1 minus 1, that is equal to 0. So what I'm getting? Average of the current over complete cycle is 0. It is 0. Now here, instead of sine omega t, I can write this equation even as I0 cos omega t. And if I'm substituting here as a I0 cos omega t, I have to find out integration of cos omega t instead of sin omega t, and even if I'll simplify it, I'll come to the same result, that it is 0, and this indicates that whenever we are taking average of alternating current or alternating EMF over a complete cycle, it is always equal to 0. It is same as the result which we got from the instantaneous value. But here we have applied proper mathematical procedure for finding average of a continuous function. Now as I'm getting this 0, this quantity is of no use for me. Then let me try for the half cycle. Now let me see what is average value over half cycle. When I want to find out that average value over half cycle, I can consider either positive half cycle or negative half cycle. And when I'm considering either of these, what change is there? Only limits of integrations will be different. Rest of thing will remain as it is. Now, what will be limits of integration? From 0 to t by 2 for half cycle. But here I know that when I'm taking average of I, means actually I'm taking average of sin omega t. Because varying term is sin omega t. And due to that, here instead of finding directly average of I, I'll find out average of sine omega t, and then I'll multiply that with I0 because I0 is the multiplying factor which is constant for the integration, and due to that I'll find out average of sine omega t and I'll multiply it with I0, or I'll multiply it with peak value. So average of sine omega t is given by integration from 0 to t by 2. Why t by 2 is coming? For half cycle. Sine omega t dt divided by integration from 0 to t by 2 dt. Now again I have to find out integration of sine of omega t. ये तो वही आना है जो हमने अभी देखा है, integration of sine omega t, and same thing now again I have to repeat here. So integration of sine omega t minus cos omega t divided by omega. Now here we are having t by 2 term. Earlier it was t. Naturally upper limit is t by 2, lower limit is 0. So here I'll get t by 2 minus 0, means it is t by 2. So the entire term of denominator will become omega t divided by 2. If we further simplify this, we get 2 divided by omega t in bracket. Now I'm keeping this minus sign inside as it is. If you want, you can take it outside also, but I'm keeping inside. So minus cos of, instead of this t, I'll substitute upper limit omega t by 2, and minus, we have to substitute lower limit. So minus of cos of omega 0, that is nothing but cos 0, and this minus with the minus here, it will become plus, and here we can write this as 2 upon omega t in bracket minus cos pi plus cos 0. What is value of cos of pi and cos 0? These will substitute here. Value of cos of pi is minus 1. So minus 1 into minus will get here plus 1. Cos 0 is plus 1. So overall this we get as 2 upon 2 pi multiplied by 2. So this 2 and this 2 will get cancelled and we get 2 upon pi. Now what is the value of 2 upon pi? 2 upon pi is 0.637. Now what this 0.637 is indicating? It is giving me average of sine omega t over half cycle. What is average of sine omega t over complete cycle? I know it is 0. And now I am getting average of sine omega t over half cycle. Once I get that, now from this I can find out average of current over complete half cycle, as well as average of EMF over half cycle, just by multiplying their peak values with the term 0.637. So average of current over half cycle is given by 0.637 into I0, and average of EMF over a half cycle is given by 0.637 E0, that is the peak value of EMF. And in this way we can find out average value of current, alternating current or alternating EMF over a half cycle. Now as these values are non-zero, can I use these values for measurement with the help of ammeter and voltmeter? Again I'll say no. What is the reason behind it? The reason here is that this is giving me only half cycle. I'm not getting complete cycle, and these half cycle values are not correct as per the consideration, because total effect I'm not getting, and due to that now we have to think about some other technique here, and for that we'll find out root mean square. we say that the new value of alternating EMF or alternating current we have to find out, and that is root mean square or effective value. Its other name is effective value. So even if someone asked effective value, you should be able to write that, or you should be able to tell what is effective value, what is its value. So don't get confused there. Root mean square is nothing but effective value. So what is here? I have said RMS value. What is that RMS value? RMS means root mean square. RMS means root mean square, because each and every time I can't say root mean square. Always in short, I say RMS value. Now what is the requirement of this RMS value? What is need of this RMS value? As I told you earlier, ammeter and voltmeter for alternating EMF or for alternating current, they are not measuring instantaneous value, or they are not able to measure average value, because average over a complete cycle is 0. Now as average over complete cycle is 0, it is required to use some another technique to measure the value of EMF or current, and for that purpose we required RMS value. And this RMS value, or from where this RMS value come, that we'll discuss in brief here, and then we'll move for the exact how we get that RMS value. When I talk about this RMS value, first of all, I know that alternating current or alternating EMF, they are changing their direction continuously. As they are changing their direction continuously, then can I measure that in terms of magnetic flux or in terms of magnetic field? Because these are the terms which are related with this EMF and current. But I know that magnetic field as well as magnetic flux, they are also changing their direction continuously. As they are also changing their direction continuously, there is no chance of using these terms for measurement of EMF and current, because as EMF and current, they are behaving in a similar manner. B and phi, they are also behaving, or they are also alternately changing. So over one cycle, I say their average is also 0. Now, if this is the situation, can we not able to measure EMF and alternating current? Is it not possible to measure it? No, that is not the case. Then we have to think about using a property which is independent of change of direction of AC. As I know that in AC, all these properties or all these quantities, they are changing their direction repeatedly. So now I want to search such a property which remains constant or which is not changing its direction. I'll not say constant, it is a wrong thing, but it is not changing its direction. Now, which is that term? All of you are knowing that whenever we pass current through the circuit or through any appliance, it gets heated. Means electrical energy is converted into heat energy, or I know that heat is generated there. And this heat which is generated, it is proportional to square of current. As it is proportional to square of current, and square of current, whether that current is positive or negative, its square will be always positive. So I say that heat is not changing continuously its direction as the AC signal is changing, because square is always positive. And due to that, we can use this property, and generally this heat, you have studied at your school level, that heat generated by the electricity is given by I square RT, is given by I square RT, and here we are going to use the same concept. I consider this circuit. In this, I am using a simple resistor which is connected to alternating EMF source. Now when I am connecting it to alternating EMF source, I say that alternating current is flowing through the circuit and direction is shown. Sometimes it is in the backward direction and sometimes it is in the forward direction. It is changing continuously. Now here, for time being, I say that the current which is flowing through this circuit is I is equal to I0 sine omega t. When alternating current I is flowing through this, which is I0 sine omega t, means its peak value is I0, and it is flowing through this R for time t, then heat produced is H. As this is the heat produced in this circuit, which is given by H, directly I am not able to write here it as H is equal to I square RT as I write for DC, because here it is changing continuously. As we say that H is the heat produced by alternating current I with peak value I0 over one cycle. One cycle means how much period? T is equal to 2 pi by omega, and this amount of current is flowing through the resistor R. As H is the heat which is produced, how much amount of heat is generated there, or how much amount of heat is there, that first of all I have to find out. So I write that H is equal to, see again, as it is alternating, I want to find out it over entire cycle. आज के लेक्चर में हमें बार बार ये इंटीग्रेशन यूज करना है, बार बार हमें उसका एवरेज निकालना है, उसका टोटल निकालना है. जैसे मैंने बताया पहले ही कि न्यूमरेटर एवरेज में न्यूमरेटर क्या था, टोटल इसका रीडिंग था, तो यहाँ पे हमने सिर्फ न्यूमरेटर लिया है, तो ये क्या दे रहा है मुझे, टोटल हीट दे रहा है. Am I finding average? No. It is the amount of heat generated over a complete cycle. So it is integration from 0 to t I square r dt. I square r dt because I'm taking it over dt. Integration is taken over dt. Now r, it's constant. I have to substitute value of I, that is I0 sine omega t, but here we have I square, so I0 square sine square omega t r dt, and limits of integration are from 0 to t. Now I0 square is not changing with time, r is also not changing with time, so these two terms are constant of integration. We can take this outside of the integration. We can write I0 square r integration from 0 to t sine square omega t dt, and now we have to simplify this. For simplifying, for this sine square omega t, I'll substitute this you have studied in trigonometry, that sine square omega t or sine square theta is equal to 1 minus cos 2 theta by 2. Theta is nothing but omega t. Now, this equation will substitute in this our earlier equation, and we can write H is equal to I0 square R as it is. This 2 we are taking outside, and inside integration we have 1 minus cos 2 omega t dt. Now we find out integration of this, and its integration, because this is the term which is remaining constant, which is not changing, I0 square r by 2. Integration of 1 is t. Integration of minus cos of 2 omega t, minus sign will remain as it is, and it is sine 2 omega t upon 2 omega. How this omega is coming, that we have discussed earlier. Again, limits of integration are from 0 to t, and further we'll simplify this. So we get, now I'm substituting upper limit and lower limit. Lower limit is 0, so naturally this will be 0, and sine 0 will be 0, so entirely it will be 0. So we have to substitute only upper limit. लोअर लिमिट की बात नहीं करनी है, 0 है तो वो 0 ही आना है. तो जब हम अपर लिमिट सब्स्टिट्यूट करते हैं, we get I0 square r by 2. Now instead of this t, यहाँ आएगा कैपिटल T, साइन ऑफ 2. What is value of omega t? Omega t is nothing but 2 pi. Why it is 2 pi? Because omega, this t will be replaced by capital T, and omega t from this equation, see here, omega will go to this side on left side, so omega t will be 2 pi. So we are substituting here 2 into 2 pi divided by 2 omega. So how much it is? Sine 4 pi. What is sine 4 pi? Sine 4 pi is 0. As it is 0, this entire term becomes 0, and what is left? I0 square r by 2 into t. So it is I0 square r by rt by 2. We'll consider this as our equation number 1, and this is giving me heat generated by alternating current in one complete cycle. I'm getting this heat as heat generated in one complete cycle, and now that generated heat is depending on what? It is depending on I0 square r, time period of that alternating EMF or alternating current, and 2, which is constant. So this is giving me heat generated. Now if I pass steady current I through the same R, same circuit I am having, only now I have replaced this from alternating to a constant some DC voltage. As now I am connecting DC voltage here, I say that current flowing through this circuit is now constant. As the current flowing through the circuit is constant, if I am passing certain current I through this resistor such that it is passed for the time t is equal to 2 pi by omega, which I have taken time period earlier, then same amount of heat H is produced, and that heat is given by certain equation. But before that मुझे ये क्या करना है, यहाँ पे थोड़ा समझने वाली बात है. पहले हमने क्या किया था, यही सर्किट यूज किया था, यही रेजिस्टर यूज किया था. यहाँ पे हमने AC कनेक्ट किया था. AC कनेक्ट करने के बाद एक कंप्लीट वन साइकिल के लिए मुझे हीट कितनी मिली थी? I0 square RT by 2. अब मैं क्या कर रही हूं, आई एम रिप्लेसिंग दैट AC विथ DC. DC तो मुझे कांस्टेंट वैल्यू देने वाला है, तो करंट भी यहाँ पे कांस्टेंट फ्लो होने वाला है. हाउ मच करंट इज फ्लोइंग? करंट इज I. द अमाउंट ऑफ करंट फ्लोइंग हियर इज I. जब ये करंट I फ्लो हो रहा है, तो वो करंट मुझे कितने टाइम के लिए पास करना है? T is equal to 2 pi by omega. जितना मैंने ऊपर पास किया है उतने ही टाइम पे मुझे यहाँ पे भी पास करना है, और मैं इतना करंट पास करूंगी यहाँ से कि मुझे सेम अमाउंट ऑफ हीट जनरेट होनी चाहिए जो कि मैंने एसी जब पास किया था तब मिली थी। जब मैंने एसी पास किया था तो एच हीट मिली थी। अब मैं करंट इतना पास करूंगी इतने टाइम के लिए कि मुझे अगेन आई विल गेट दैट हीट एज एच। नाउ when I'm getting the same amount of heat, that heat, as I'm passing current I, that heat will be I square RT. R is same, T is also same. Now, how much amount of current I'm passing here, that is I, and how much current I have passed earlier, that is small I, that is I0 sin omega t, that is the difference. Now, when I have passed current, alternating current, I got this much amount of heat. When I passed DC current, I got this much amount of heat. But the amount of heat in both of these situations is same. Heat generated is same. As heat generated is same, I say that left hand side of equation 1 and 2 are same. As left hand sides are same, we can equate their right hand sides. And if we equate their right hand sides, if we compare these two equations, I say that RT will get cancelled, and what is left? I square is equal to I0 square by 2. If I take square root on both sides, I can write it as I is equal to I0 upon root 2. Here, I can write that in that case, how much amount of DC current is equivalent to AC current? The amount of DC current for which same amount of heat is generated by AC is I0 upon root 2. Now this amount of current I am comparing for DC and AC in terms of heat, or I am coming to this conclusion in terms of heat. Now this is on the part of heat, but what is actual root mean square value of current? That also I have to verify. And for that purpose, we'll move towards actual root mean square value of alternating current, and we have to find out its relation with peak value of current. And for that, now again I'll consider my alternating current I is equal to I0 sin omega t. I want to find out actual root mean square value or actual RMS value. So what is there? First of all, I have to go for square, because as I want to find out root, so I have to take root of what? Mean value. Mean of what? Mean of square of that. So I'll move in opposite direction here. First of all, I'll find out square. So what is square of this current? I say that I square is equal to I0 square sin square omega t. I0 square sin square omega t. Now I have taken square. I want to find out its mean. Mean means what? Average. We have seen average earlier, and I have to take its square root. So here I'll write that IRMS, that is root mean square of current. I'm having square, then I have taken its average or mean, and then I'm taking its square root. So this is representing root mean square. What I say? Root, mean and square. What is average of I square? Again we come to the average point which we have discussed earlier. So we write average of I square as integration of I square from 0 to t over dt divided by integration of dt from 0 to t, that is for complete cycle. We are finding average of I square over a complete cycle. अब ये देखा इतना बड़ा बड़ा इक्वेशन तो पहले ही डर लगने लगता है, कितना डिफिकल्ट होगा ये, है ना? तो घबराने की कोई बात नहीं है. तो हम क्या करते हैं, थोड़ी देर के लिए स्क्वायर रूट को हटा देते हैं ताकि हमारा टेंशन थोड़ा सा कम हो जाए, क्योंकि एग्जाम में तो लिखना ही पड़ेगा, डर के नहीं चलना है. तो लेट अस रिमूव दिस साइन स्क्वायर रूट. इफ यू वांट टू रिमूव दिस स्क्वायर रूट साइन, what we have to do? Take square on both sides. If I'm taking square on both sides, I write here I square RMS is equal to, ये स्क्वायर रूट का साइन निकल गया, ये आ गया यहां पे, राइट? अब हमें सिंप्लीफाई करना है. सिंप्लीफाई करना है तो क्या करना है, I0 स्क्वायर का वैल्यू सब्स्टिट्यूट करो. ये किया सब्स्टिट्यूट हमने. अब ये हमने सब हीट के इसमें भी लिया ही था, वहां पे सब ये चीजें आई थी हमें, तो ज्यादा यहाँ पे डिस्कस करने की जरूरत नहीं है. I0 स्क्वायर साइन स्क्वायर ओमेगा टी डी टी डिवाइडेड बाय टी. अब आपको तो सबको पता ही हो गया भाई, ये कहाँ से टी आ गया, काफी बार हो चुका है पहले ही, तो अब पता ही चल गया. तो आगे क्या करना है, इसको I स्क्वायर को बाहर निकालना है, टी को बाहर निकालना है, और साइन स्क्वायर ओमेगा टी का हमें इंटीग्रेशन लेना है, जो कि हम पहले ही ले चुके हैं. तो हमें पता है व्हाट इज इंटीग्रेशन ऑफ साइन स्क्वायर ओमेगा टी डी टी ओवर 0 टू टी, इट इज टी बाई 2. तो हम यहाँ पे फिर से वो सब करते नहीं बैठेंगे, हम तो सीधा सीधा लिख देंगे भाई यहाँ पे कि इट इज टी बाय 2. हाँ, लेकिन एक बात ध्यान में रखो, अगर एग्जाम में आपको आता है ये कितने मार्क का क्वेश्चन है ये देखना है आपको. अगर ज्यादा मार्क का क्वेश्चन है तो ये आपको बताना पड़ेगा कि आपने साइन स्क्वायर ओमेगा टी का इंटीग्रेशन कैसे लिया है. हाँ, लेकिन ज्यादा टेंशन लेने की जरूरत नहीं है. अगर भाई समझो नहीं याद आ रहा है इतना, तो इतना याद करके लिख सकते हो, बहुत ज्यादा कुछ नुकसान नहीं होने वाला है आपका. तो इतना ध्यान रखना है. मैथ्स अगर टफ भी जाता है तो इतना ध्यान रखो और लिख दो, उसमें कोई टेंशन नहीं है, मार्क्स तो मिल ही जाएंगे. इफ आई सब्स्टिट्यूट दिस I स्क्वायर RMS इट्स इक्वल टू I0 स्क्वायर. कहां से आया, यहां से आया, t यहां से आया, और इंटीग्रेशन ऑफ साइन स्क्वायर ओमेगा टी डी टी टी बाई 2 यहां से आया. हमने सब सब्स्टिट्यूट कर दिया. अब ये टी गया और ये भी टी गया, तो बचा क्या है, I0 स्क्वायर डिवाइडेड बाय 2. एंड व्हाट आई एम डूइंग, आई एम टेकिंग इट स्क्वायर रूट नाउ, बिकॉज यहां तक तो हमने किया, लेकिन ये जो हमने छोड़ दिया था उसको छोड़ना तो नहीं है हमें, तो फिर हमें लेना है. तो ये स्टेज पे हम क्या करेंगे, अब इसका स्क्वायर रूट लेंगे, और इसका स्क्वायर रूट क्या, लेफ्ट साइड का स्क्वायर रूट क्या आएगा, IRMS. व्हाट इज स्क्वायर रूट ऑन राइट साइड, I0 स्क्वायर, स्क्वायर रूट इज I0, 2 स्क्वायर रूट इज √2, and we get IRMS square is equal to I0 by √2 is equal to 0.707 I0. So here we are getting RMS value and this is equation 4. अब मुझे ये एक इक्वेशन आया जो कि मैंने एक्चुअल रूट मीन स्क्वायर से लिया. मुझे पहले एक इक्वेशन आया था जिसे मैंने थर्ड इक्वेशन बोला था, इसमें ये था डीसी करंट और ये थे पीक वैल्यू ऑफ अल्टरनेटिंग करंट. अब मेरे पास दो इक्वेशन है, एक 3 नंबर का है, एक 4 नंबर का है. अगर मैं ये दोनों इक्वेशन कंपेयर करूं तो मुझे क्या दिखाई देता है, इन दोनों के राइट हैंड साइड सेम है. अगर इनके राइट हैंड साइड सेम है तो मैं लेफ्ट हैंड साइड इनके इक्वेट कर सकती हूँ. एंड नाउ आई इक्वेट लेफ्ट हैंड साइड ऑफ बोथ ऑफ दिस. लेफ्ट हैंड साइड ऑफ थर्ड इक्वेशन इज I and left hand side of fourth equation is IRMS. So we can write I is equal to IRMS. So we come to conclusion from this that here IRMS is equivalent to the DC current which is flowing through the circuit for generating same amount of heat. And due to that, we say that this IRMS is equivalent to the value which is measured by ammeter or voltmeter, because I know that ammeter and voltmeter are measuring DC current and DC voltages, and that value is equivalent to IRMS for alternating current and alternating voltages, and due to that we say that ammeter and voltmeter, they are not measuring zero value for the alternating current and alternating EMF, but which value they are measuring? They are measuring RMS value. And this RMS value is important due to the measurement part of aspect. Now, here, as we have seen this RMS value, as well as we have seen average value, as well as we have discussed in instantaneous values. Instantaneous value is the value at particular instant. Average value we have taken over the complete cycle, it is 0. Even we have taken it for half cycle. For half cycle it is 0.637 times of the peak value, and IRMS value is 0.707 times the peak value. अब यहाँ आपको ये लग सकता है मैम आपने तो I is equal to I0 sin omega t लिया. अगर हम cos omega t लेते हैं तो क्या होगा? Nothing to worry. You'll get same result with even cos omega t. अगर आपको लगता है तो आप cos omega t लेके जो हमने सब प्रोसीजर की है उसी प्रोसीजर से आप सॉल्व करके देख सकते हो. It is homework for you. Try it with I is equal to I0 cos omega t. Now same, everything whatever I have applied for current, same thing I can apply for alternating EMF, and I'll come to same result here also. And here we are getting the as RMS current. Similarly we can find out RMS EMF also, or I say RMS voltage also. In short, we'll see what is peak value, what is average value, and what is RMS value. Or in brief, we'll revise the entire lecture. Peak value for EMF is E0 and for current is I0. These are peak values for alternating EMF and alternating current. Then average value, which we have studied, that E average is equal to 0.637 E0, and I average, this 0.637 I0, 0.637 factor is constant here. What is changing? I0 or E0. Then the last is RMS value, that ERMS is equal to E0 by root 2, that is equal to 0.707 E0, and IRMS is equal to I0 by root 2, that is equal to 0.707 I0. On graph, we'll see how to represent this. This is a sine wave. It may be representing EMF, current, whatever you want, you can consider. And I know that this is giving me the maximum value, which we call as peak value. We call it as peak value. So here, this is representing E0. E0 peak value. Then this value. Now I want to go for average. Average is 0.637. It is less than RMS. So naturally, here this value is average value. and here this value is its RMS value. Now here, as I told you, this is representing average value, which is 0.637 times E0. इसका 0.637 times है. This is E0. E0 multiplied by 0.637. So that value is nothing but average value. And then RMS value. RMS value is 0.707 times E0, and that RMS value we are getting here. Now here I am representing voltage wave. Similarly, we can represent current wave, and we get here I0, here I average, and here I RMS. So in today's lecture, we have studied instantaneous value, average value over complete cycle, over half cycle, and RMS value for alternating current or alternating EMF. Today's lecture was more mathematics lecture than physics lecture, but without maths, physics is incomplete. तो मैथ्स तो थोड़ा करना ही करना है, और अगर थोड़ा डिफिकल्ट जाता है तो ये लेक्चर आप 2 बार 3 बार लिखो, उसमें जो पॉइंट्स है वो नोट करके रखो. You have to do writing practice, which is most important, because you will require RMS value again and again majority times. So you should know what is RMS. And on this, numericals might be asked majorly, or MCQs might be asked. Yes, for theory, you have to prepare derivations on this article. On those derivations, questions might be asked. So whenever you are preparing for theory, you have to keep in mind all these things. ये भी मुझे पता है ये टॉपिक थोड़ा सा कॉम्प्लिकेटेड लग सकता है, क्योंकि काफ़ी सारा मैथ्स था. इतना मैथ्स बहुत ज़्यादा हो गया होगा, but if you practice for it, it will be very easier for you.
Few questions on today's topic are listed here. Majority questions are of 1 mark or 2 mark, but this topic is very important to understand basic concept of AC circuits or AC signals. Thank you for watching. See you soon.